All right, I'm not singing or playing music. So, okay, so we're transforming functions today. Last year you transformed objects like triangles and squares and stuff. So now it's functions. So that's all what this whole class is about, is a whole lot of function garbage. So, parent functions. So these are your definitions, and just so you keep aware, parent function means the function you start with. Okay, so it doesn't have to be anything crazy, but it could be something nutty. But they'll always tell you f of x is always your parent function. The image usually has this little prime, or they call it something else like g of x. Okay, but they'll use the word image to say that's the one after the transformation. So just remember the words vertical and horizontal, what they mean. If displacement is used by itself without an adjective, it means up or down. Phase shift, left and right. And dilation is to stretch or widen the graph. Okay, so there is a note here, horizontal displacement and vertical phase shift. Just make sure you use the word horizontal or vertical first. That's the primary word that you're looking at. Okay, so use your calculator. I can't bring my calculator up because I don't have that kind of technology to do this. Again, I'll say it, I'm not as cool as Murray. However, f of x equals x squared. You're going to graph that. So you have that ability, you have your calculator in your y1 spot, because remember, f of x is the same as y. In the y1 spot, graph x squared. Now that should be a parabola that looks like this, right in the middle of your x and y axis. Okay. Now, in y2, so graph the image. y2 is x squared minus 5. So remember, this guy is always our parent function, the x squared, so we're going to leave that in the y1 spot. And we are going to replace each one of these, A, B, C, and D. Those are going to be in our y2 spot, just so we can see the change. So you have x squared minus 5. What did that do? Hopefully you've graphed it already. If you haven't, pause and do it. It should have moved it down 5. That's pretty straightforward. When you do x squared plus 4, that takes the whole function, just shoves the whole thing up 4. So this one here, down 5, it would have moved it down, something like this, and up 4 would have looked something like that. That's it. That's a transformation. If you add to the function or subtract to the function, it moves it up or down. So now, here, we're adding to the x, not the function. So remember, erase your y2, keep your y1 as x squared, okay, keep it as x squared, and make this one y2. Now what do you think is going to happen? Okay, and then what actually does happen. So hopefully you realize that this one moved it to the right. Okay, hold on. Okay, it doesn't do that. So let's make it a little thicker. There we go. I got this. There we go. There we go. So it should hit the x-axis. I just having trouble. There we go. So it should move it to the right 2. Okay, that's kind of opposite of what you would think. However, that's what it does. It's crazy. Okay, now this one, maybe you already know what's going to happen. Try it anyway. Okay, and this one should move to the left 7. So, to sum up, if you're adding to the function, like over here, if you're adding to the function, so x squared isn't changing, I'm just subtracting 5 or adding 4, that moves it up or down, exactly the way you would think it should. Okay, this one, if you subtract the x value, so remember this is inside the parentheses, that's often a way you can see it. If it's inside the parentheses and you subtract something, it moves it to the right 2. If you add something in the parentheses, it moves it to the left 2, or 7, depending on what the number is. Okay? If you don't believe me or whatever, if you're like, this is crazy, try it with x cubed or the absolute value. Remember, absolute value can be found in, it looks like this. Absolute value can be found by going to math, move over to num. Well, it's not capital. So move over to num, and it's the first choice. And that's will give you the absolute value. Try it out. Turns out they all work exactly the same. All right. With this, now this is kind of a way that you're going to see it. You have, this is the question that's being asked. Now this is f of x. So this is your parent function. Okay? So this is your parent function. It doesn't matter what it is. It never has to be right on the origin. Makes no difference. But what they're telling you is you're subtracting 3 from the whole function and adding 2 to x. So to transform this, I'm going to choose red for this one and blue for that one. To transform this, I have 3 points that I can see. Those 3 points. I'm going to move those 3 points and then sketch the graph. Okay? So I'm going to add 2 to x. And when I add 2 to x, that means I move the opposite. I move negative value. So this point is going to move here. This point is going to move over 2. And so they're all going to move over 2. Then I'm also going to subtract 3. So I move down 3 from this spot. So this spot, hold on, I'll pick orange. So I move down 3 and I move to here. Forget red. This one moves down 3. This one moves to the left, and now it moves down 3, which is here. And this one moved to the left, and then down 3 to here. A lot of things here, so I'm going to just erase the miscellaneous stuff. But in the end, you move down 3 and to the left 2. Yeah. To the left 2, down 3, to the left, oh, this was right here. All right, and that's it. So then you graph it, and that's done. This one I'm going to do in one step and not do the extras because that was a little confusing. So I'm going to do this one in blue. So this one is x minus 5, so it's going to move to the right 5, and it's going to move up 6. Okay, remember when it's in parentheses, it's opposite of what you think, and when it's outside the parentheses, it's exactly what you think. Okay, it's the y-axis that you're dealing with. So I take this point here, and I move 1, 2, 3, 4, 5, 4, 5, 6, and we do the same thing with each one. Good. And then each point that we see, okay, and there it is. So these are different ways that questions could be asked. So you can sketch the graph, you know, and just do what it says. So just to give you, sum it all up here, if it's outside the parentheses and you're adding it to the function, it moves up and down. When it's inside the function, when you're adding it, it moves it to the left. And when you're subtracting, it moves to the right. Sorry. Okay, so consider this graph, x cubed. Y equals x cubed. If we want to translate it, what would the resulting image be? So the image of y would be inside of the parentheses, remember, is left to right. So if I'm moving 5 units to the left, I'm moving in the negative direction for x, so I add 5. So remember, inside the parentheses is your left to right, and it's always opposite of what it should be. Okay, and 7 units down, that's the y, or adding or subtracting to the function, minus 7. So what did we do to get from x squared to this one? If this is our parent function, and we want to get that, this one moved, it's negative, So it moved to the right 1, all right, GHT, and it moved up 3 because this is up and down and this one is left and right. All right, hopefully you understand that. We can multiply. So now when we multiply, it does exactly what you're going to think, but in a kind of weird way. So when you do this again is your parent function. We're going to start with this one. And then we multiply the function here for this one. And for this one, we're going to multiply the x. Now the result is pretty much the same, but for different reasons. Okay, I hate when I can't erase. Okay, so if we put these all in our calculator, you'll see this is the parent function right here. Nice small values. When we multiply to the function, and you may want to look at this on a graph. So this is, if this is your blue one, this is your original. We're going to graph that kind of like here. This is just a regular graph. Okay, it should have hit the x-axis, but I can't draw. So then, if we want to do this one, it's going to mush it. See how these numbers get really big? Not huge, but really big. So what happens is it kind of stretches the graph. So it looks skinnier, but it's actually stretching it out. The values are going up faster. And that's really what you have to understand. So this is stretching the graph, or making it so that it goes up or down, depending on which direction you're going, faster. So this, when we multiply to the x here and then square it, the numbers go up even faster. So this one, if we make this black, it will be even skinnier. Okay, so they all really do the same thing. This one we're multiplying to the x. So it's multiplying to the x first and then squaring it. So it's kind of changing what x is in a way. So the basic idea is if you multiply times the function, and n is an integer, it's a whole number, it stretches or widens by a factor of n. Okay, and if this one also, it stretches or widens by a factor of 1 over n. And that looks confusing, so this kind of summarizes it up right here. For our purposes, no matter what you do, when you're multiplying, you're going to stretch the graph out. Okay? Now, if it's a whole number, it's going to stretch the graph out. So if you want to, you can try like 1/2 x squared. This is an example of something that's between -1 and 1. It's a fraction. And when we multiply by a fraction, if this is your original, what's going to happen is it's going to widen it out. Okay? So when this number is a fraction, we're going to get wider. And when this number is a whole number, or not between -1 and 1, then this stretches it. Those are the key words that you have to know. All right? Try it out. We're going to do the positive and negative thing later, but that's the idea. All righty? Have a good day.